Hi everyone, I'm Cheryl. In this problem, we're asked to find the area of the surface 4 plus 5x plus 6y above the region that's described as x squared plus y squared is less than or equal to 4, which is a circle of radius 2. So I know that I can find surface area by using a double integral. So the surface area is the double integral over a region ds. Now, if my function f and its partials are continuous, I can write this as the double integral over a region of the square root of 1 plus the first partial with respect to x squared plus the first partial with respect to y squared dA. All right, so let's take a moment and figure out what our partials are. So our first partial with respect to x I'm taking the derivative with respect to x, so I'm going to treat any y as a constant. So the derivative is just 5. The partial with respect to y, I'll be treating x like it's a constant, and I take the derivative, which will give me 6. So I can go back to my formula now and say that this is the double integral over my region of the square root of 1 plus 5 squared plus 6 squared dA, which is the integral over the region of the square root of 1 plus 25 plus 36 dA. Now, this is a constant, so I can actually pull it outside. This will be the square root of 62. So I'll pull that outside, and I get the square root of 62, the double integral over the region dA. Now, if I want to continue and work on a double integral, I can. However, take a look at that integral of dA over the region. Basically, what I'm asking for is the area of this region. Because it's a circle, I have a geometry formula for that. So I can simplify the process and just write this as the square root of 62 times the area of that region, which is going to be pi r squared. And I know that r is 2, so that's pi times 2 squared, which means I have 4 times the square root of 62 times pi. It's a surface area, so square units. I hope that was helpful. Thanks.